2.2 Day 2, more on functions and their graphs. Our learning goal is still the same, that you'll be able to build functions that model relationships between quantities from existing functions. Today we're going to learn about piecewise function. And that means that you have two or more equations that are specified over a given domain. So a piecewise function looks like this. So you have two or more equations. We'll start off with two. And then they're going to give you a specific domain. So the first equation is for those numbers, x values, that are smaller than 0. If the number is smaller than 0, then you plug it into the first equation. Let me color code this so that it was minus, sorry. And the second equation is only for those x values that are greater than or equal to 0. So we're going to evaluate certain values of x. We'll do f of -3, f of 0, and f of 4. So first you figure out which function you should plug your x value in. -3 is smaller than 0, so we're going to use the yellow equation. And all you do is plug in the x value, and you get your answer, -18 minus 1. So f of -3 is equal to -19. So our input was -3, our output was -19. The second x value they want us to evaluate is when x is 0, which would be your second equation. So I'm going to use the white chalk, and you plug x into the second equation. And you'll just get 0 plus 3, which is 3. So f of 0 is 3. And we're not solving for f. We're just finding the output given the specific input. 4 is also greater than or equal to 0. So I'm going to here again use the second equation. So 28 plus 3 is 31. And that's how you evaluate the piecewise function. So make sure you check to see the x that they give you and figure out which equation you should plug it in based on your domains. So these are your restricted domains. And these are your two equations. Now I'm going to show you how to graph the piecewise function. So with graphing, they don't give you values. You're going to set your own values. You only need 2 points, at least 2 points, to make a straight line. If it's a square root graph, you may need 3. But lines, you only need at least 2 points. And so what you're going to do, first of all, I'm going to start with the yellow equation. These are for x values smaller than -3. Well, you have to start at these two x values. You have to use those. And then you can select your whatever you want for your second. So for the first graph, here's x, here's y. You have to use -3, and then anything smaller, so I'll use -5. And then this one, we have to use -3 and anything larger, so I'm going to use 0. So you can choose what x values you want to plug in. Now, the only difference is, and I know people are saying, well, -3 is not smaller than -3. Well, that just means at -3, you're going to have an open circle. This is not included. But if you don't start at -3, you're going to miss the values between -3 and -4. So those decimal values. And then this one is included, which means this one is going to have an open circle. This one will have a closed. So you're going to plug in -3 into this equation. That's an F. And for these values, you're going to use the second equation. Okay, so we're going to plug those in and get our points. So -3 plus 3 is 0. -5 plus 3 is -2. So you'll plot those. And then over here, you have -3 minus 3, which is -6. And 0 minus 3 is -3. Now, sometimes your points will start on the same point, and that's okay. That's my Y, this is my X. All right, so my yellow graph, -3, 0. Remember that one is an open circle because it's not included. And -5, -2. I didn't go over enough. One, 2, 3, 4, 5. And it's good if you use graph paper. And then this line is going down because we only want X values that are smaller. Now over here, my points are -3, -6. Remember, this one is included. And 0, -3. And those are going in this direction because they want X values that are larger. And there's your piecewise function. This function, or piecewise function, has 3 different functions, so I'm going to have 3 different tables. The first one is for f of x equals 0. And they want me to use X values smaller than -3. Remember, I have to start at -3, but this will be not included. So it'll have an open circle. And then I'll choose something smaller than -3, like -5. And this means my Y values are all 0. My middle function is f of x equals -x. My X values are restricted to -3 and 0. -3 is included, so it'll have a closed circle. And 0 is my stopping point. This one is not included. It'll have an open circle. So if I plug in -3, I'll get 3. If I plug in 0, I get 0. My last function is f of x equals x squared minus 1. And I'm going to start with 0. This will be included, so it'll have a closed circle. Then I'm going to pick something larger, 1 and 2. Remember, parabolas have to have 3 x values, at least. And if I plug in 0, I'll get -1. If I plug in 1, I'll get 0. If I plug in 2, I will get 3. So now let's graph. Okay, my first function, I have -3, 0, which is an open circle. -5, 0 is, of course, you know, is included. And so we're going to go in this direction, because everything's smaller. My middle graph, -3, 3 is included. 0, 0 is not. And they cannot extend beyond those 2 points. My last graph is the parabola. starting at 0, -1, which is included, 1, 0, and 2, 3. And make sure you curve it up because it is a parabola. Okay, our last concept, we're going to learn about the difference quotient, which is very helpful when you're looking for average rate of change of functions, kind of like slope. Average rate of change between functions. And it's similar to the slope. And this is the difference quotient formula, and you need to get to know this. And h can never be 0 because you can't divide by 0. So we're going to use this difference quotient to help us simplify different functions. And then we'll learn about the meaning of it later. Find and simplify. And I'll do 2 examples. Okay, here we go. So this is example 3a. Okay, so they're going to give us the function f of x equals 6x plus 1. All right, so according to the quotient formula, or the difference quotient, we have to find f of x plus h, because we don't have that. We have f of x, we just don't have f of x plus h. So what that means is you're going to plug in x plus h for x. So you're going to just plug that inside of here. It might be easier if you simplify it. So you're going to get 6x plus 6h plus 1. All right, so we have f of x plus h. We have f of x, and h is just a constant. So this is my difference quotient. I'm just going to plug everything in that I have. Okay, so f of x plus h was 6x plus 6h plus 1 minus f of x. I'm going to put it in parentheses because that minus is for both. All over h. And then it says to simplify it, so we have to simplify this. So I'm going to have to distribute this negative, and I'm going to get 6x plus 6h plus 1 minus 6x minus 1 all over h. And then you just simplify on the top. This one cancels, and the 1's cancel. And then you're left with 6h over h. The h's cancel, and you're left with 6. And make sure you show all steps. Okay, here's our last example. We have f of x. We just have to find f of x plus h. So everywhere you see an x, you're going to plug in x plus h. X plus h. X plus h. All right, see that square? A lot of students forget that that means to FOIL. That means you have to write it twice. And then over here, I'm going to distribute the -3. All right, so just leave that negative on the outside, and I'm going to FOIL it. First, outer, inner, and last. Now you can distribute the negative. And you're going to get negative x squared negative xh plus h squared. Oop, I made a mistake. Remember, distribute the negative to all of them. Minus 3x minus 3h plus 1. So that's going to give us negative x squared minus 2xh minus h squared minus 3x minus 3h plus 1. All right, now we have f of x plus h. Now we're going to set up our difference formula. And I'm just going to plug everything in. So this is f of x plus h, this whole thing right here. And then it says minus f of x. And they gave us f of x. I'm just going to plug in f of x. They'll always give you f of x. All over h. All right, you're going to distribute that negative, so be careful. So we have negative x squared minus 2xh minus h squared. Oh, let me scoot this over because it's going to be long. Minus x squared minus 2xh minus h squared. Make sure you write everything right. So now that'll be plus x squared plus 3x minus 1 all over h. All right, let's see if anything cancels. The x squares cancel. The 3x cancels. The 1's cancel. So let's write what's left. Negative 2xh minus h squared minus 3h. All right, I'm going to divide each one by h. And I'm going to get negative 2x minus h minus 3. And that is the simplified difference quotient. I'll write it out here so you can see it better. And that concludes this lesson. As soon as I finish erasing.